Okay, now let us start with the third question in kinematics of simple harmonic motion. Given a simple harmonic motion, x equal to 0.5 cosine. This is a cosine equation. Take note, this is a cosine equation. And the unit is in x in meter, time in second. So be careful, yeah? This is a cosine equation, and the unit of x is meter, time in second. So here. The unit is very important because it determines the correct unit for amplitude and omega. So I just want to say again, if the x is unit meter, the amplitude also have the same unit meter. When the time is in second, the omega is per second. So the unit for amplitude depend on displacement. The unit for omega depend on time. So we must always check. If the displacement is cm, then our amplitude will be cm. If our time is millisecond, then our omega is per millisecond. So you have to always check the unit first. Write it down here. Okay, finish that. Now, good. The first question, calculate the time required by a body to move from the equilibrium position to a point 0.25 meter away from it. Okay, this question asks about the time with position. Time position. So what formula do we use? Yes, we use the xt formula. So we use back this formula. Okay, this formula. Okay, before we go to the question A, I just want you to always compare the given displacement time equation with the general equation. Write the general equation just beside the given equation. So from here, the general equation is x equal to a cos omega t. If the question give cosine, then our general equation also cosine. If the question says sine, then we also use sine. Okay? So from here, we can see that the amplitude is 0.5 meter. The omega is 3 pi. Okay? This is how we compare. We got the amplitude and omega already. Now, we want to find the time for these two positions. We have two positions here. We have the equilibrium position and also the 0.25 position. So we have the two positions. We need to find time for equilibrium and time for 0.25. Then the time required is just the difference in the time, t2 minus t1. Okay? Now, use the xt equation. So for equilibrium position, this is the equilibrium position. So you just put into equilibrium position, just substitute the x with 0, equal to, which is 0.5 cosine 3 pi t. Okay? Remember, always change your calculator to radian because this is using pi. Yeah? Radian. For this chapter, simple harmonic motion, your theta must be in radian. Okay? Your theta must be in radian. Now, before you go forward, we sketch the cosine graph. So you see, this cosine equation is actually this graph, cosine graph, isn't it? So actually this motion actually is start from the amplitude. Okay. It start from the amplitude. Now, the body moved from equilibrium. To 0.25 meter. Okay. Move from equilibrium. That means start from the equilibrium position. Okay, start from equilibrium position. Which is 0 equilibrium position, and go to 0.25 meter away from it. So 0.25 meter away, so the graph actually goes down. It's not go up. The graph actually goes down. So 0.25. So we can say equilibrium position is here. Yeah. 0.25 is over here. X equal to negative 0.25. So our displacement need to put a negative sign. Negative sign. Why put a negative sign? Because the graph goes down. It's not goes up. It goes down. Yeah. So x equal to 0.25 meter. That's why the negative, because here it just says 0.25 meter away from it. It can be above the equilibrium, can be below the equilibrium. But as you see the graph, from equilibrium to 0.25 meter away from equilibrium means the graph goes down. So this is 0.25 meter below the equilibrium. Okay, below the equilibrium. So negative 0.25. Good. So we find the time for both of these positions. Okay, let's do it. For the first one, we divide. We still got cosine 3 pi t. And use calculator, reverse cosine, and we got pi over 2. So our time 1 is actually 1 over 6 seconds. This is our time 1. Now our time 2, you know, this is the x1 and this is x2. So our time 2, how to find time 2? So just solve it. This is negative 1 over 2 after you divide. So cosine 3 pi t, and then so 3 pi t is equal to you use calculator, you will get 2 over 3 pi. Okay, you will get 2 over 3 pi. So cut off, and we will get the time t2 is 2 over 9 seconds. 2 over 9 seconds. So we got the time 2. Now the time required is the difference in the time. So it is equal to 2 over 9 minus 1 over 6. So what is the answer? 0.056 seconds. Okay, 0.056 seconds. That's the time required to move from equilibrium to 0.25 meter below the equilibrium position. The difference in the time is 0.056 seconds. Okay, now next, what is the velocity and acceleration at this time? 0.55 seconds. Oh, got two things they ask, velocity and acceleration, given time. So we need the formula velocity time and acceleration time, because given time us to find velocity and acceleration. Do we have this equation? No, we only have the displacement time equation. So we need to differentiate. So velocity time equation is dx dt. So the x equation, displacement equation, is just now 0.5 cos 3 pi t. So 0.5 cosine 3 pi t. This time our displacement start with cos. Special, start with cos, not sine. So that's why I want to discuss this equation, because our displacement is a cosine equation. Now, differentiate this versus time. So first, differentiate outside. 0.5 is still 0.5. Differentiate cos, you get negative sign. Remember, you have negative. When you differentiate cos, you get negative sign. And then 3 pi t, just copy. Now differentiate inside. We got 3 pi. The constant 3 pi. Okay, t 1 minus 1 becomes 0. So t gone. Yeah, t to the power of 0 is 1. So we can say we differentiate 3 pi t, we get 3 pi. Okay. Now 3 pi multiplied to the front, we got the negative put in front. So negative in front. So 3 pi multiplied 0.5, we get 1.5 pi. And then sine 3 pi t. So we got our velocity time equation. So the next is substitute the time into the equation. Make sure this is in radian. You must be in radian. Okay. So velocity equal to negative 1.5 pi sine 3 pi times 0.05. So our velocity is negative 2.14 meter per second. That's our velocity. So negative means is moving downwards. Okay. Now the acceleration time equation. Again, we differentiate the velocity time. Differentiate A is dv dt. So velocity equation is this is our velocity equation. Okay, just copy this into here. Now differentiate with time. So differentiate outside, differentiate inside. Now differentiate outside, negative 1.5 pi, maintain. Differentiate sine, get cos. No negative. Differentiate sine, get cos. And then 3 pi t, copy. Then differentiate inside, you get 3 pi. Okay, 3 pi. Then multiply to the front, 3 pi. So here become negative 4.5 pi square. Because you have pi multiply pi, get pi square. 3 multiply 1.5, you get 4.5. Okay? Negative 4.5 pi square cos 3 pi t. Okay, congratulations. You already got the acceleration time equation. So this time, make sure in radian, substitute the time to get the answer. Very simple. Negative 4.5 pi square cosine 3 pi times 0.05. And what's our acceleration? It is negative 39.57 meter per second square. That's our acceleration. Negative 39.57 meter per second square. Okay? Good. Now, okay. Now, this is a acceleration equation. Now, find the C. Calculate the velocity and acceleration of the body at displacement 0.05 meter from the equilibrium position. Okay, now the question asks for velocity and acceleration, but given displacement. So this one asks for the velocity displacement equation and also the acceleration displacement equation. Okay, we already have formula for that. No need to differentiate. The velocity displacement equation is this: plus minus omega square root a squared minus x squared. Acceleration displacement is a equal to negative omega square x. So our displacement now is 0.05 meter. He said displacement 0.05. Yes, this is a positive displacement. Make sure you put the sign. This is a positive displacement. No sign means positive. No sign means positive displacement. Very important. So it's a positive displacement. So just substitute into the formula. Plus minus. This one also must write plus minus. And omega is, what is our omega? Yeah, 3 pi. 3 pi is our omega. So 3 pi. And then what's our amplitude? Yeah, amplitude is 0.5 meter. So 0.5 and minus 0.05 square. Okay, so the answer is plus minus 4.69 meter per second. So the plus minus here means at this displacement, the object maybe is going up or going down. It can have two possibilities. Maybe the object is velocity going up. Maybe at this position, maybe the object is going down. Yeah, at the same position. It has two possibilities. Okay, maintain the positive negative sign. Now, to find acceleration displacement is a negative omega square x. So just use the formula. Omega is 3 pi. Omega is 3 pi. And our x is 0.05. That's our answer. Negative 4.44 meter per second square. The negative means to the left. Okay, or going to the going downward. Okay, or going downward. Okay. So the negative means the direction. Yeah, can say either to the left or downwards. Okay, so very simple, right? Make sure if given time, asked to find velocity, acceleration, you just use velocity time, acceleration time. If given displacement, asked to find velocity and acceleration, use the velocity, displacement, acceleration, displacement equations. Okay? Remember, always change to radian. That's all for question 3. See you in the upcoming questions.